energy is really good, and I'm really glad to give this talk today. How many people here are coming for your second time? Who are all like not here the first time? Oh, so the crowd is, most of you guys are coming for the first time. Yeah, that's pretty exciting. How many people here are TypeScript developers? Okay, we are seeing a good number of hands. How many people here work with the language that has types? Now, can we see a show of hands? Even if you are TypeScript, it's okay. Any language that has types. All right. Yeah, hands down. So, cool. So today's talk, what I'm gonna speak about is how we built some AI-powered workflows to refactor like large TypeScript code bases. Okay. And a little bit about me. So my name's Danny Akash. So I work as a founding engineer in Browser OS. So Browser OS is a browser that works for the AI agents. So right now the product is live. You can go to browseros.com and download. It's an open source project. And the way we built Browser OS is initially it was built entirely on TypeScript. So we forked Google Chrome. We built a custom layer inside that ships our own Node.js engine where we write our TypeScript code and we exposed the browser to the AI agents. So what happens is when the agents want to interact with the browser, it can communicate through that layer. Okay, today's story is how I converted that browser's engine from TypeScript over to Rust, why we did it, how we did it, and how AI helped us. So you can find many of my open source projects. So I have quite a lot, and I am also like actually looking for contributors. If you have some free time, would like to like help me build my tools, feel free to like reach out to me. I'll be here only after the talk. I'll be available to network. Cool. So May, something interesting happened. So how many of you here heard about the bun Rust rewrite? We have one person. We have 3 people so far, 4. All right. It is quite a feat actually. I didn't actually expect a public open source project on that scale, like rewriting its entire code base to Rust. But what happened is they had almost like million lines of Zig code rewritten to Rust in like 11 days. So some interesting things about this rewrite, it was done with like 64 parallel agents. So, and 4 work trees. How many people here know what's a work tree? Anyone heard about the term? 2 people. Okay, let me tell you, work tree is an interesting concept in Git. What happens is every time you create a new branch, everyone knows what's a branch, right? Every time you create a new branch, it will create a new folder for it. So instead of you having to create 5 branches and switch between branch, by default, what happens is switch within the same folder. So it's okay for humans because whenever you switch to a branch, you will only focus on one branch. But for AI, it can focus on multiple branches, correct? So in order to give it access to all the branches, we create work trees. So if I create 5 branches, it will assign 5 work trees, 5 folders will be created. And all folders can be like exposed to AI simultaneously. So they made 4 such work trees, had 64 agents work on it and created over 6,500 commits. And they used an interesting file called porting.md, which basically is just a file that has like rules explaining how to write code while it's doing the refactor. Then they had an interesting review concept called adversarial review. So the idea behind adversarial review is you go checking for issues like how this code can break. You imagine yourself as the negative person in the room. If like 5 people are saying, yeah, let's go to the trip, we are like planning to the trip, there will be one guy who is saying, no man, that day doesn't work. You know, that one negative person. This is adversarial review. You basically take the negative stances, how this code will break. Then you have the test suite. So one unique advantage Bun had during this rewrite is Bun is one of the most well-tested software. They had like an amazing test suite, and they had to make sure all of their test passes. This is quite important. So with this, they actually managed to rewrite entire Bun from Zig over to Rust. And when I was like reading the story, initially I was like slightly skeptical. I was not sure, is it a marketing stunt or something? But when they actually finished it, I realized, yeah, right now AI is so mature, we can actually achieve such huge refactors. What I didn't know is in 1 month, I would have to do such a refactor eventually for my own product. I didn't knew it at that time, but this refactor helped me a lot. So here we built a huge TypeScript service for our browser. Okay, the server had to be rewritten in Rust, and we are also like getting ready for launch. We already had 400 active users with the browser. We had to swap it from TypeScript to Rust, and we had to do a launch. And we had the launch yesterday. It was a very successful launch. We got like over 2,000, 3,000 users new from that launch. So this is the product. It's called Browser OS Neo. So the idea behind this browser is basically it's a browser designed for your agents. You get like a different browser. I can actually show you. This is Browser OS Neo. So what happens is you don't use the browser. The agent will use the browser, and then you can see what the agent did. So right now I had it checked for Netflix prices. So you can see the agent's actions. If I want to get a replay of what the agent tried within this browser, I can just open it and it will directly show me all the actions it did throughout for getting the prices. Now this browser, it was very, when we initially started, we didn't have any issues. It was like a very good project. We managed to like build it within a month because we already had experience building a different browser before. And when we had to like ship it, when users started using it, we started noticing few issues. Like, sorry, my bad. So we had to like run many agents at once, because the moment any user like gets a powerful browser to do their work, you cannot expect them to use it one agent at a time. At a time, even myself, I started using like 5-6 agents at once. Even like last month, tax filing and all, I had it fill tax filing portal and everything directly from this browser only. So with JavaScript, I mean TypeScript, we found it a little bottlenecked, like handling the multiple requests and passing it back and forth between the browser. And we also had to ship an entire node runtime along with the browser, because whenever we had to like run TypeScript code, we need to ship our own specific environment, which has become like quite a challenge. And many of the browser internals we built, the tools we built for extracting the DOM, getting queryable structure for the agent, everything were built with Rust already. We wanted to get that native performance and a native crates directly within our project. So we had a discussion with the team, and then we decided, yeah, it's actually better if the product launched with Rust. We will have like better memory structure. We will have more parallelization. A lot of efficiency gains are to be done. So we decided to move. So how do you rewrite a server which is already built? It was actually just now a freshly built project. So if you go to our GitHub repo, this is our browser OS repo. You can still see class server TS. It's an open source project. Entire browser OS was built open source. So this archive contains the TypeScript project, and within the actual app, we have the class server Rust. The class server is a name we gave to the agent because we primarily designed it to work with open class. So we named it class server internally. Now, how do you go about doing this rewrite? Before AI, like before the whole vibe coding thing came into the picture, such a project is not possible, especially like 1 week before launch and all. It's definitely not going to be possible. rewriting the entire core engine of the browser. But we already knew this was a task that was already pulled off by the Bun team. We actually thought this is actually a good challenge also. Let's see, we'll try to rewrite it to Rust, see how it goes. If everything works, fine. Otherwise, we'll ship it with the TypeScript package itself. Now, usually when you do like refactors on two things often break. First is type safety, usually like breaks on the compiler level when it's running. So when your application is running, like some type drift happens, like a compiler will be expecting a number, but it will be getting a string. It will throw a runtime error, it will break. And there is also a lot of mechanical changes. You first have to learn a new language. You have to learn the language's best practices. And we have to see some best practices for TypeScript is definitely not going to work for Rust. So how will we like port them over? It's a very mechanical problem. So agent is good at one thing. It can clear the volume part. If you give it a lot of mechanical work, it will finish all those mechanical work. So our goal in this refactor was, how do we break this down into the most basic mechanical task? So if you give a browser like, hey, do this 1,000 times, the refactor will be complete. And this is actually the same thing I learned from the Bun Rust rewrite. So if you look at their blog post, they do a lot of prep work. So the idea behind this prep work is you create a queue. You basically break your task into a lot of errors and you pass the errors across like different agents and fix them one by one. So we had to think of a similar pattern to achieve this. So here is the first structure of our class server, which was built with TypeScript. So what happens is we have an AI agent. This can be any agent. You have Cursor, Claude, Codex, browser always works with anything. The agent will communicate via the class server, which is a MCP REST endpoint. You know, agents talk to other applications via MCP. We are also primarily MCP. And then what happens is we can connect to Chromium internally over CDP. So Chromium exposes certain tools to actually connect with AI. We connect over that. And our refactor layer is this class server should work in a way the agent and CDP are unaffected. So whatever the agent previously did with the TypeScript server, we needed that same pattern, but just in a newer language. This is just the reasons why we had to leave TypeScript. I already explained it. It's like one native binary. You get extreme memory safety, and we can share Rust crates between like the browser native tools and our actual core business logic. Now, this is how our Hono RPC app looks like. Can everyone see this? Okay. How many people here have worked with Hono before? Hono. Anyone here knows Node.js in general? You have like, oh, good, a lot of Node.js developers. So basically what happens is, this is a TypeScript Hono app. This app type that you are seeing contains the type of the entire server. So the idea is Hono has this interesting concept called Hono RPC, remote procedure call. So when you create the server, it gives you one TypeScript interface, which contains all the definitions of the server. What are all the GET requests? What are all the POST requests? What body that the POST request expect, and what kind of response type it gives back. And this Hono RPC is great if you are working on a monorepo where server code and client code lives together, because now I import the server's type, app type, and directly use it within my client. So I can just say client Hono, and I can do client.api.v1.sessions.get. This is nothing but /API/v1/sessions. It's just that route, but in TypeScript format, and we had full type safety. So when we built it, it's a perfectly type safe project. Now, how do we get this type to Rust? we had amazing types, but trapped in a single language. Everything is in like a Hono app type. And the type of routes, I definitely cannot use it in Rust because all the TypeScript types are in a different language. So then we decided to take that contract out of TypeScript first. A contract is just an agreement between the server and the client, correct? We decided, yeah, first let's write the contract outside. Is the mic on? Hello? Yeah. Okay. Am I still audible to you guys? Even to last two? Okay. Then I can just go ahead without the mic. And to establish the contract, okay, this you might have already shared or not. So there is this thing called Open API. Who doesn't know about Open API?
Check.
Open API. Okay. It's not Open AI, it's Open API. So this is a open source spec where you write YAML files or JSON files on how your server's request and response will look like. Okay, this is actually the first task we gave to the AI. Hey, read our entire TypeScript code. Okay, and write this YAML file. This will be a huge YAML file. I want you to make sure the entire server's request and responses are translated into this YAML file. Now, creating one file is very easy for AI, no matter how tedious that file is. So it ended up creating thousands of lines of contract. So you have all of these API paths. We had like many more routes. I only put like 2, like sessions, stats, how this API is gonna look like. Then we built a CLI, a code gen command. What it does is it will read that YAML file and it will generate TypeScript types and Rust structs. So a type is basically you defining how a number is a number, a variable is a string, correct? And the YAML file basically add everything, how our API is going to look. So we built a CLI that takes that YAML file and writes the type interfaces for TypeScript and Rust structs, which is the types that Rust language will understand. So now our code is becoming deterministic because you know AI's outputs are non-deterministic. If you ask the AI same question 5 times, there's a good chance it will mess up the 5th time because it's a non-deterministic outcome. But if you run the TypeScript type checks 100 times, you will get the same 100 results, correct? So first we established this check command. So if you look at bun run code gen claw API check, it's a script which runs in CA and makes sure that the checks are always passing regardless of the refactor. So whenever AI does and it decides to use like string instead of a number, the CA will fail. Next is using the YAML file into 2 separate projects. One is a Rust project which uses like Rust APIs. Another one to the TypeScript client. Like we had the server, we also add UI for the users. And that UI also depended on that exact contract. So we generated a placeholder for its place which uses the Open API spec. Now here is the best part. With the new contract becoming the source of truth, the server now can be anything. So at this point, we had a TypeScript server. Now we just had to build a Rust server that implements the contract. So whenever AI makes a mistake, the contract will fail and we know we are in the right direction or not. So if you look at the stats, we had like 98 commits overall to achieve that contract. Because now we established a finish line, 0 to 100% what it looks like. When the contract is fully like implemented, it's 100% and it overall took us 98 commits. Now this is how the Rust code will look like. So first of all, this is me importing one of the generated contract from OpenAPI. And then when the logic runs, we collect the response is aggregate. And finally, when it sends that response back, I have a check here. It has to match the contract that I imported. The aggregate contract should follow the contract that we established previously with OpenAPI. And you will start to see parallel shapes. So what we had on the left side is, it's a drizzle schema. Basically, our app still had a local SQLite database. So when we established the contract, it had to make sure the same SQLite table is usable within Rust. So for TypeScript, we had this drizzle definition, which shows how integer is represented. And you can see on the Rust side, it's the same thing. Instead of integer ID, we had pub ID I64, which is Rust's way of defining an integer. Likewise, everything has not null here. There, if it is optional, we have that option prefix. So we are defining same JSON object in two different languages. And also we had to make sure the architecture remains the same. Just because I'm rewriting it to Rust doesn't mean all our best practices, framework practices should go up in flames. So we decided for the ORM, instead of using drizzle, the Rust will use CORM. And for Hono, we use Axum, which is another web framework for Rust. And for schema validation, we previously used Zod, instead moved to Serde and Schema RS. Finally, we also used like code quality tools. This is the highlight. So Biome is a code quality tool for TypeScript. It enforces like good code quality practices. If anyone knows ESLint, Biome is a faster alternative for it. And for Rust, we also adopted Clippy and Rust FMT. So it's not like we decided to go with slop. We enforced a good architecture for the AI. So whenever the AI is starting to write a new route, we had claude.md file instructing it. Hey, if you're writing a new route, it has to be written with Axum. And all those routes should be validated with the Serde. And finally, once it writes the code, we run like lint checks using Clippy and Rust FMT to make sure the code quality remains the same between TypeScript and Rust. So first of all, instead of migrating, this is an interesting part. So the users already had a database on their machine. So browser OS doesn't have a cloud network. We don't have any separate database on our server. Given the sensitive nature of us being a browser, we keep everything locally on the user's machine. So they already had a SQLite database on their machine, which they are actively using. So what we did is, instead of rewriting that SQLite database, the server will simply adopt that database. So if they're using TypeScript, the database will be working. The moment we swap the TypeScript with Rust, the same database remains in place. Rust will start making the request and Rust will do the writing. So users need not worry about migration breaking anything. So we initially took the drizzle-owned SQLite and shipped the CORM, Rust-based database layer. And we removed the drizzle migrations table in the user's machine. And it went smoothly. Now the entire database is part of Rust. And finally, how do we know this port was correct and the database was working? So we had 205 tests, cross-server tests. So the idea behind this test is we have different curl requests. That curl runs with the TypeScript first using bash. And once it gets the responses, we will run the same curl with the same database structure with the Rust server. And we will expect the same results. So this gives us extremely like accurate vision on where things are breaking. Because if the database has the same value and the server's response comes out incorrect, you know there's a logic breaking somewhere. And it helps us trace the issues immediately. And we had adversarial reviews with 37 parallel agents. So we had multiple agents on different work trees. And we made sure every agent has a blind adversarial review. And it had overall, by the time we finished it, we had 37 adversarial reviews done with 10 issues like identified after the refactor. So we managed to fix it all. And by the time when we finished the Rust rewrite and shipped it with the browser, pretty much all the responses worked as expected. So both TS server and Rust server, we shipped it together. Like 50% users were on TypeScript server, 50% were on the Rust server. Same calls. If anything is like slightly different or we detect any error, we just capture those errors. That's the easy way to identify, right? When you ship it to a small amount of users. So instead of like shipping it to all 400, we shipped it to like 50. And internally, our team itself were using the new Rust version. And we had Sentry and all this error capturing mechanisms. We were like capturing all the small errors and we are creating a divergence ledger, like where things are breaking. And then we had another agent swarm run through those issues. We got like small issues weren't very complex like we expected. It turns out to be like smaller issues, and agents made sure all the issues have been like fixed and also like completely reviewed. Finally, by the time we built the language, there is one small problem we had called the drift, code drift. So previously the server and client were both on TypeScript, and the client imported the server's types directly. So we didn't had that drift problem, but now the contract is a YAML file. So let's say I update the YAML file and I update the Rust server, but I forgot to update the client. There is a chance the type will fail. On runtime, this will fail. So to avoid this drift, we had to build some CLIs. So if you look at our open source pull request, it has like almost 2552 tests today. And what happens here is we have this check called claw API conformance. Okay, hopefully the. So we have this claw API conformance check. So the idea behind this check is the API properly updated across all the clients? And we also have claw API generated code, which makes sure the generated code is used when we did the TypeScript or Rust type checks. So with this, we actually managed to port the entire product over to Rust. And we also knew all the checks are passing and all the users, they didn't even like notice a difference. So we shipped it to all the users. We were like waiting for responses. We had our Discord group and everything ready. And finally, the first message we got was one user message, hey, did you guys push any update? And I was the one online at that time. I'm like replying to him, yeah, we pushed a major update. And it's like, now I feel the browser is really fast. All of a sudden, like I'm seeing my parallel work is like getting done quickly. Well done. And I'm like, okay, thank God. The only feedback we got was actually positive. So we were like confident it got shipped. And yesterday we also launched it to the public. So today, if you go to browseros.com, you will see the BrowserOS Neo available for download. So here is how the refactor went. We took the TypeScript contract. We wrote it in a YAML file, OpenAPI YAML file, which basically explains how the server looks. And we established a pattern for the AI agent to follow that contract. And we built a lot of CLIs and test cases to make sure that contract is passing. And this allowed us to actually achieve a smooth migration from TypeScript to Rust. And we achieved it in 3 days. So that's like crazy fast. In fact, we achieved it in 1 day. The 2 days are just us testing it with users. All that 98 commits happened in 1 day. That's the fun part with the AI. Once you give it like any task, it works night and day. Now, if you think, okay, moving from TypeScript to Rust, I had all of this trouble. I also have one more small case study. This I did for my personal project called Agent Terminal, where I had to bring stuff from Rust over to TypeScript. So Agent Terminal is basically a terminal I built. Initially, I built it so I can learn Rust. It's a very simple. And the idea behind this terminal is when you are working with multiple agents, it's getting very difficult to understand what the agents are doing, what projects are actually being worked on. So if I have to like show you, this is agent terminal, and this is how many AI agents I run parallelly with this terminal. Now you know why I needed a separate terminal for this. When you're working with many agents and a lot of tasks, it was becoming difficult. So I was working on agent terminal and I also launched it. It's currently available open source. Everything was going great until I had an idea. When I was building this agent terminal, I accidentally built a nice protocol to stream terminal over the network. So agent terminal uses PTY, and PTY is usually stream as bytecodes. And when I built agent terminal, I built it using Tari, a Rust framework. And the Rust framework needed a TypeScript rendering layer. And for that, I converted the terminal messages instead of bytecode into JSON. And I streamed it as JSON. Then I had the idea, if I can use that JSON stream properly, I can stream the terminal directly to my mobile. Correct? And instead of using SSH, I can use this terminal on my phone and I can do my work on my phone. I had that idea. So now the challenge went in reverse direction. So a Tari desktop app built with Rust has to speak to Expo mobile app directly using TLS. And this TLS required a lot of internal plumbing. I had to do cert pinning, MDNS, lot of tools. But the interesting part is the wire protocol that I built was plain JSON in Rust. So if you look at this type share, this is a type that I'm sharing between my Rust and the TypeScript endpoint. I had the auth, which is a token, subscribe, which is tab ID, resume, which is tab ID, and the last sequence number. I wrote one tool called the TypeShare CLI, which takes this Rust type and directly converts it into TypeScript type. This time, instead of me having any open API YAML file, I just wrote one CLI that directly converts it. So whenever I have a terminal object emitted like this, it will become a TypeScript type creator like this format. I think everyone will be familiar with this. It's just a type with multiple OR. So now what happens is, I have my protocol, which basically representation of my terminal locally. I run it through Xtask. It creates a protocol gen.ts, which is the same terminal represented in TypeScript. So the idea here is, once you have a JSON object well established and you know every argument, every key and value in the JSON structure, you can convert it across language. Previously, building this tool used to be a huge chore. It was very hard, going through every branch of the code, figuring out what is the equivalent in TypeScript. But once you have AI will do all this work, all this mechanical task automatically. And now what happens is, I have a streaming protocol where any action I do on my phone gets translated directly to a terminal action on my PC, on my Mac. So suddenly you have terminal on your phone. The actual terminal is in Rust, but an Expo phone with TypeScript can control it. And I had some issues while doing this because I'm not following any standard OpenAPI protocol. First of all, the number of bits Rust and JavaScript uses is different, because Rust uses 64 byte. Rust's numbers are actually longer. JavaScript only uses 53 bits. It had issues. So I had to write a logic on the Rust side to make sure all the numbers are 53 bits only. Then also optional types often tend to be absent when running the CLI. So what happens is, in Rust you get null, in JavaScript you have undefined. Usually whenever null is representation. So I had to figure out how to not omit null values in the TypeShare CLI. So from this, 4 ways to move type across a language. Types are important. Now, how do you move it across language? First of all, Hono RPC. So this is great if you are having single language, like the initial claw app server. So both server and client directly can import the type and use. Now, Open API is how I moved the server from TypeScript to Rust, because I created an intermediate language. Third is type share. So type share is basically me in my terminal creating a CLI that shares the type from one language to another. Okay, this is good if you are building some custom protocol. For personal use, I wouldn't recommend it for like enterprise scale applications. Just go with Open API. The other cases. Finally, you have the and mirrored, where you just handwrite the same type in both languages. Cheap if you are doing like 1 or 2 functions, but for an entire project, it has high chances of breaking. So once you get the source of truth ready, the next real drift is the CI. You have to make sure all these source of truth can be verified on the CI. As soon as you get the drift on CI, any AI slop, if it breaks the contract, can be immediately captured on the CI level. The agents will take care of the volume. However many 1,000 files you want to edit, the agents will work on it. And however many times they get it wrong, they will retry it. You just have to make sure the contract enforces that honesty. Like whenever it's breaking something, the contract forces the agent to know something has broken. So the playbook, both Bun and ours, Bun's is already in the website. We are also publishing our playbook. Feel free to like capture it, use it in your own project. Bun's write-up is extremely well written. I learned a lot from that, so I highly recommend everyone to like try it in your own projects. Okay. Pretty much everything is done. I can skip to the end now. TypeScript superpower is types, but when you want to move away from the language, it's the contract. You convert the type to a contract. Any questions so far? I'm open for questions. And also this concludes my talk. So pretty much like now moving on to the question section. Yeah, you can raise your hands. We have someone asking questions. Okay, so that is called a type share CLI. It is just me building a custom code to generate that type. So this is Agent Terminal's code. Agent Terminal is also open source. Look at it. This is all the commands my terminal generates. And if you can zoom in, you will see you have reattach, spawn PTI, which is create a terminal, write PTI, which is just writing. And when something resizes, the terminal has to re-render, like when the window resizes. Everything is a different function. And what I did is, I read all of these functions and converted them into their TypeScript equivalent. On data, on resize, on ready. This is the type share CLI. It's a custom logic that I wrote with the agents that converts the command from TypeScript over to like, from Rust over to like TypeScript. The idea is, as long as the functions are properly defined, I know what JSON is going to happen, it can be converted to another language. I just directly tried it. Okay, any other questions? Yeah. Okay, what is the trade-off we got before and after migration? That's the question. The first thing is JavaScript is single-threaded. I think everyone knows that. It has that event loop concept. And the way agents work, okay, one agent opens like 5 tabs on average when you ask it to like find something. And the user will have 5 agents running at a time. Now imagine that's like 5 agents controlling 25 tabs. And you already know how heavy Chrome tabs can be, correct? So with all of that in place, having them in JavaScript the JavaScript started becoming the bottleneck because it had to be single threaded. So we decided to try workers. And when we tried workers, we had to clean up the workers. We had to clean up all those resources. It became very complex to reduce the memory as the work kept on progressing. And you also keep the browser open throughout your workday, correct? 8 hours. So the amount of garbage collected memory like rises also. So Rust gave us that memory safety and the parallelization that we currently lacked. So the after like rewriting, the performance like skyrocketed within our product. Cool. Other questions? Is my answer clear? Yeah. Yeah. Someone give him a mic. Yeah.
Why browser OS? Because we already have browsers via browser MPCs when we use Cursor or Cloud Code. So those IDs already can access the browsers and can run it. So what is the advantage of browser OS?
Okay, so the question here was, we already have browsers. Why we built a new browser for this? How many of you actually used those browsers to get your actual work done? Can someone raise your hand and say, hey, I booked my tickets using this browser so far? So the problem is those browsers take something built for humans and give it to an AI agent. So for AI agent to see the browser, it has to take screenshots. It has to run document.query selector. It has to do a lot of like hacky things to interact with the browser. But what we did in browser OS is we exposed the data via accessible labels directly to the agent. So to read a page, it doesn't have to screenshot the entire page. The amount of tokens we started saving were huge. So even in my current browser OS dashboard, you'll see it used like 51% fewer tokens. We are actively benchmarking it. And it is more accurate too when it like uses the actual browser backend to make the clicks instead of using document.query selector. So the clicks tend to be natural. We also make sure it runs on your machine, so it also won't trigger the bot detection. And finally, you get this audit log. So if your agent made any mistake, you can go back to this audit log and see where it made that mistake. That was not possible in the existing browsers. So speed, performance, token efficiency, audit logs, we basically like turned the browser into something very, very agent friendly. Does that answer your question, Bro?
Yeah, it's clear. And I have a follow-up question that, so you said it bypasses the bot protections. So what kind of bot detections?
Usually bot protections get triggered when you access the website from a remote server. So AWS or any other data center, if you access the page from those servers, bot detection will be triggered because they want to reduce the traffic on their site. But since it uses your actual machine, okay, where you actually get your work done, and it also uses the regular Chrome interface to interact with the pages, it rarely ever triggers bot detection. Got it? Yeah, and also our user agent is just plain Chrome. We don't have any special user agents for this. So you get the same page that you get from Chrome here. So if you're using any service like Firecrawl or browser use where it runs on a remote server, you use it to get some engineering task done. But here in browser OS, you actually get your personal work done. You can close Jira tickets. You can write updates, a lot of actual browser work. Yeah. Anyone else? How many questions?
Hello.
Yeah.
For refactoring the code base from TypeScript to Rust, how much token you have burned? like cost?
We don't exactly know. We use the $200 plan.
Oh,
So we honestly didn't measure how much tokens it cost.
because we are writing like features in our application means like we will hit the limit like that. Um, so whole code base you have refactor right from TypeScript to Rust. That may cost like how much tokens? But you told no, right?
The thing is, as long as you're using the $200 plan, you won't hit any limits. So what agent are you using?
We are using Sonnet 5.
Sonnet 5. Okay. I'd recommend for bigger tasks, get a higher subscription, that's all.
So actually for this you Fable 5 or Opus 4.8, like which model?
The architecture was done with Fable.
Okay.
Most of the outline instruction work, but the actual mechanical work was done by Opus.
And the sub-agents you spawned like that.
Yeah, Opus dynamic workflows, we use that.
Oh, thank you.
Also, if anyone wants to like get your own personal AI subscription, I highly recommend getting OpenCode's Go plan. It's like really good, and you spend only $10.
So,
Yeah.
so why did you use Sentry rather than Datadog and Synos? And what are the valuable events you capture because the users are at 400 plus? And how will you capture the most possible event that may fail?
Okay, why did we use Sentry? Because Sentry is the easiest one to add to any product. That's all. We don't have anything against Datadog. Second, Sentry captures any exception. So it's not like we are targeting any specific exception. If something breaks, JavaScript error is thrown on the client side or the server side, immediately Sentry will record. We just capture all the record and fed it to the AI agent. That's all.
So mistakes are captured by AI agents, right?
Captured by Sentry, then we used a Sentry's MCP to pass everything to the AI agents.
Best use case that we need to use Mono RPC in our application. Any use case that will convince my company to use this?
How will I convince your company? Okay. So the thing is, RPC is good only if the company feels that benefit, they will convince. You can like write a blog post or something, but I am not sure how that convincing process works. We can connect offline after this. Discuss.
I'm currently building a software for myself, which my QA is using, right? It is a software with AI agent is connected. It will use Chromium to automate. I will give the form URLs alone. It is an 50 plus fields forms. It will fill all the forms and give me a output. It uses a Chromium to do this task. How come your browser helps me solve the
You
any
can
problems?
simply replace Chrome with this browser and it will do the work faster. That's all.
For that I can use Chromium, right?
Chrome,
Plus.
I'm trying to tell you the amount of time it takes for the browser to fill the form. This browser will fill it up faster. And we are also planning on a developer version where you will get the console logs and network requests as replayable assets. So eventually, if your QA is using it, they might find it helpful.
Any own MCPs to connect to your browser specifically?
So this browser supports 7 agents out of the box, and it gives an MCP that you can connect to any agent.
Sorry to interrupt, guys. We'll have a talk session, or we can have a connect time during our break, which is after the second talk. So thank you, Danny sir, for your insight and engaging session. Let us give a big round for Danny sir.
Also, thank you guys for your attention. I'll be available here. You can talk to me after the event.
So moving on to our next speaker, we have Ms. Roja Nyanave, a senior software engineer at Tremble with 10 years of experience in software engineer. She specialized in React, TypeScript, modern front-end development, and AI-powered applications. She is also a core member of Chennai React, a tech speaker, hackathon judge, and a mentor actively contributing to and empowering the developer community. Today she will taking us to TypeScript 7, same types 10 times faster, what actually changed. Let's give a warmly welcome for Roja Gnanavel ma'am.
Hello. It's audio. Give me a second. So let me share my screen. Okay. My screen is not visible. Hmm. There's no one there. I have shared empty accounts. I hope my screen is visible, right? Okay. So how many of you know like last month the TypeScript 7 has been released? Can you raise your hand? Okay, that's cool. So, and the next question is like how many of you tried to upgrade your version to TypeScript 7? Okay, that's great. Okay, so today the topic about is like TypeScript 7, same types 10x faster, what actually changed? And before getting into the topic, let me give a quick introduction about myself. I'm Roja Gnanavel, lead software engineer at Trimble, work as a, sorry, work as a lead software at Trimble with 10 years of experience in software engineering and core member of Chennai React team. And apart from, you guys know what, like 2 years back, exactly on this is the first venue I started my tech journey before 2 years. And now I'm really pleasure to be standing in front of you all. Okay, so, okay, let's see what exactly Microsoft has announced actually. So what they have announced like TypeScript is 7 is up to 8 to 12x faster, and there will be like a compiler editor will be very fast, and the language server crashes has been reduced significantly. These are the three features they have released in TypeScript. Okay, this optimization is not like happened on overtime actually. In 25, they have announced the project about TypeScript 7, and they have released the public beta at 26, and after they got more feedback from millions of downloads and tested in multiple Microsoft teams with multiple open repositories like VS Code and Sentry, Playwright. These are the open repositories they have tested, and finally they have released the TypeScript 7 last month. Okay, so we all know now, right? So TypeScript 7 has been released. What was the reason that has for the release actually? They have not introduced any new feature, but exactly they have implement the compiler. The reason, the first problem is like how many of you know what exact problem the TypeScript 6 has? Can anyone know? Okay, that's right. We all know, right? So the TypeScript compiles at JavaScript Node.js runtime. So it has some own limitation like memory efficiency, and it does not, it is a single thread as we all know, and there is no parallelism and garbage collector. These are the limitations the TypeScript 6 has previously. So now we know the problem exactly. What were the fix they have applied actually? So instead of writing the compiler logic, what they did, they ported to the Go. So what it will do, it will compile the native execution. So it gives a better memory efficiency, and garbage collector is better. There is a less runtime overhead. Everything has been managed. That is the reason the build time is become 10 to 12x faster. And the moment Microsoft announced it has been ported to Go, many developer ask the question like, why Go? Why not Rust? Why not C++? The exact problem is the previously it was written in TypeScript, right? It has like a complex cyclic data structure which won't be supported by Rust actually. If we have to use Rust means everything we have to redesign the compiler itself. But with help of Go, we no need to redesign anything. Just we can change the implementation itself. The same compiler design and we just rewritten. And one more thing we have to understand, this is not a rewritten, it is a port actually. The compiler has been ported to Go, it is not a rewritten. Before that, we have to understand what is the difference between port and rewrite. Rewrite means we are developing something from scratch and the implementation design itself is got changed. But here, we just ported, which means the compiler design will be same, but it has implementation language as written in Go. So that is the difference for port and rewrite. Okay, how many of you know like TypeScript pipeline architecture? Have you ever thought like how exactly TypeScript to JavaScript file has been converted? How many stages are there? Okay, great. So this is the important slide which we have. So the moment we start to compile the TypeScript file, what will happen? I just missed one step, okay? Before parser, we have a scanner. So scanner, what it will do? It will scan the all files. So let's take, I have one line where name equal to Roja. So this slide has been scanned. It will convert it to token. Token means like var as a one token, name as a one token, equal as a one token, Roja as a one token. So now the TS file is got scanned. Its output is token. Those token has been given to parser. Parser, what it will do, now we have a token, but we doesn't know the parent-child relationship, right? So we have to understand what is the parent-child relationship. Parent-child relationship means, what I'm trying to mean, in file, we have a function. Parser should, like compiler should understand this particular file belongs to which file. If we have a variable, this particular variable belongs to which function. So it will create the AST tree. It has like parent-child connection. Okay. So the parcel will give output as a AST tree. This tree will be input to binder. What exactly binder will do? So now we have a tree. Okay. So we have to identify, right? We need a unique identifier. So let's take it as a symbols. So with help of binder, we can create a symbol for all variable functions, for everything we will create. From binder to, it will go to the type checker. So this is the important stage in pipeline. So what type checker will do? Type checker exactly will do, it will check whether the function defined proper type, the variable defined proper type. Every type check will happen with help of type checker only. If it finds any error, we will see the error in CLI compiler. Next, what will happen? Now we have symbol identified, type check has been done, and AST has compiled. Now we will move to the emitter step. So in emitter, what will happen? Our end goal is to emit the JS file. So it will emit the JS file. So this is the core architecture of TypeScript pipeline. Okay. So you have to understand, previously I said, right, the compiler design has not changed actually. The port only, the environment only is got changed. Here you can see this is the same stage, same order, same output, only the port implementation language got changed. Okay. So Microsoft, what they did before releasing TypeScript 7, they have tested, they have upgraded TypeScript 6 to TypeScript 7. They not only tested for VS Code, they have tested all kind of open source. Those open source are Sentry, Blue Sky, Playwright, and TLDraw. You can see VS Code has the 2 million lines, and these are the like huge repos actually. They have, and the orange will be indicating the TypeScript 6 build time. And the blue is like it is measuring the TypeScript 7 build time. Okay, you can see, we'll check for VS Code first. When we are using TypeScript, the build time is 125 seconds. Once we upgraded it to TypeScript 7, the build time becomes 6 seconds and it become more 10x faster, right? Yeah, it's okay. The same they did it for Sentry and Blue Sky, Playwright and TL Draw also. Okay, now we have seen performance improvement. If the performance improving means memory also, like memory usage also important part, right? So the same thing they have tested for memory usage as well. So VS Code, the same. Previously, it was like 5.2 GB has been used, and once they have upgraded to TypeScript 7, the memory usage is 4.2 GB. So which means like there is a reduction of 18%. The same they did for Sentry, Blue Sky, Playwright, and TL Draw. Okay, so far we just talk about build. Okay, build times, how the performance has been increased, memory usage, how it is efficient. Apart from, there are few things also, like as a developer we always work in the developer ID, right, rather than build. So here is the important part, like how many of you know language server, TypeScript language server? Have you ever, like most of us have seen this actually, whenever we are typing it will give us suggestion, right? So that is those feature and all supported by language server only. So whatever we are typing, immediately the red color line underline, it will show, it will be error, right? These and all, like after upgrading to TypeScript 7, this will be like very quick actually. If you are using low end machine, what will happen? To get the error itself, it takes more time. If you are using high end machine, the suggestion will come fast. This everything has been improved now in TypeScript 7. And there are teams like Slack, Power BI, Canva. They have given their feedback also, like how the development experience after upgrading to TypeScript 7. Okay, so for what we did, like we just see the benchmark for all other repos. The same benchmark, like I have created, I have applied to my own repo as well. So it's giving a significant feed compared to previous version. What I did, like as my repo is like a confidential, so I can't show the demo. For now, for here, I just cloned the VS Code repo, okay? Is this screen visible? Okay. So in one folder, I do have two repos, the same, the VS Code only. The one repo has a TypeScript 6 version, and the second repo has a TypeScript 7 version. The setup already I have done. So what I'm gonna do here, just I'm gonna run a command, okay? Okay. The command is npx tsc-pre transconfig.json, and okay, let me remove checker for now. Okay, this command I will run. It will take a 1 second, okay? No, give me a minute. Yeah, before that, let me show you like what is the version of this repo. Yeah, here you can see, right? This particular repo has the TypeScript version as a 6.03. So here I'm trying to run. Okay, it take a 1 minute. I just want to ask you, like, how many of you know the difference between npm and npx? What is npx? Can anyone answer? Yeah, so it is the execution actually. With help of npm, like we can install package and everything. But those package we have to execute, right? With help of npx only we can execute. So it is a execute tool. Okay. Why is taking this much time? Okay. Parallelly, what I will do, okay, let's try. Okay. So now what I will do, the same thing I will run here also. Before that, let me show you what is the version of this file, this repo as. What I'm doing? Oh, sorry. Okay, so here you can see, right, this repo has a TypeScript version as a 7.0. The same command, I will run it here also, and we'll compare it. Okay, so let's start with TypeScript 6. Here you can see, so I have mentioned, right, whenever compiling happening, there are 4 stages: parser, binder, and type checker and emitter, right? Here you can see, we have a parser time, right? Parse time is a 302 seconds in TypeScript 6. Let me check the same in parser time here as well. It's like a 0.7 seconds. There is a significant improvement, right? So the next step is binder. So let's see, binder time is like 2.18 seconds in TypeScript 6. The same in TypeScript 7, 0.16. The important metrics we have to check time. The check time, as I mentioned, this is a major part. Here only all the most of the build time it's consuming check time only. It is 33 seconds. When I'm checking in TypeScript 7, it become as a 5 second. There is like a more drastic improvement. When come to emit time, so it will emit a JS file. Emit time also here 30 seconds. When I'm showing here, it is a 2 seconds. This also drastic time. So when we are checking overall total build time, it is a 55 second and it become a 8 second. The next one important thing we have to check, memory used actually. So let's move it to TypeScript 6. Here you can see memory used. You're able to see, right? So it's like almost like a 6 GB. Okay. When I'm checking in TypeScript 7, it is like almost like a 5 GBs. Okay. And one more thing I want to mention here, I said, right, it is quoted to be like a Go native implementation. By default, the TypeScript's running at like 4 workers actually. So whenever it is in type checker space, the checker has been running in four parallel workers actually. The default CLI flag will be type hyphen checkers 4. If we want to increase the checker to 8, like suppose we want to increase the more parallel work for a type checker, we can do that as well. And before changing the checker configuration, we have to ensure like we have enough CPU core support as well. Okay. So currently I'm in TypeScript 7 only. So what I will do, yeah. So here you can see, right? So I have configured as a hyphen checker 8 actually. So these of the CLI flag has been introduced in TypeScript 7. It is not available in TypeScript 6. So let me try to run. We'll see the difference between previously checker 4 and checker 8. Okay. 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 Badly it got increased actually. It may be like I'm running parallel things behind the scene. It because of the reason, but definitely the check time will be get decreased only. Okay. Okay. Now we all come to know like TypeScript 7, it will give a massive build time speed and memory usage. What we will do, like immediately we try to upgrade to TypeScript 7. But before upgrading to TypeScript 7, we have to ensure few things, okay? Okay. So how many of you using, what is the latest version you guys are using in your repo? TypeScript 5 or 4, 6? Okay. So let's assume like your TypeScript repo has been using a version called TypeScript 5, okay? What we'll do, like when we came to know TypeScript 7 has been fast, we try to immediately migrate to TypeScript 7. But never do that mistake, okay? So first try to update to TypeScript 6, because once you have updated TypeScript 6, that is a major feature release actually. So if every types has been working properly in TypeScript 6, the same will be work in TypeScript 7 also. And one more thing, there are some tsconfig changes also. In TypeScript 6, even if you miss the TypeScript tsconfig file changes, you will get as a warning only. When you are migrating to TypeScript 7, those all the warning become like a hard error, like you have to fix it. So what you do, once you updated to TypeScript 6, try to fix all the type issues, and if there is any warning related to deprecation, try to fix that as well. If everything has been fixed at TypeScript 6, you are ready to go to TypeScript 7. There is no changes, because there is no component level changes as well. And there is one more ecosystem gap actually. So if we are using plain TypeScript and JavaScript, we can update directly to TypeScript 7. But there is a certain limitations also. Angular, Vue, these are all like libraries, frameworks, right? These frameworks and all built on top of TypeScript compiler only. So they need a programmatic API support, which means let's consider Angular, okay? So Angular has a TS file and HTML file. In HTML file, we have a binder, right? The naming binder. So what the TS compiler has to do, it has to check the what name exactly the type has been bind. So those check and all, it's not possible to check by TypeScript compiler. For that, we needed TypeScript programmatic API support. So if you are working in Vue, Astro, or Angular, please wait for 7.1 version to release. Then you can happy to merge it actually. If you are working in React and plain TypeScript, you can upgrade to TypeScript 7 version. And yeah, like almost I'm going to end the session. Yeah, the same what I was said, right? With the plain React and Node service, you can update if you are using Angular Vue and wait for 7.1 release. Okay, so the takeaway of this session, if you did not understand anything, that's fine, just forget about. Just remember TypeScript 7 has been released. There is no syntax, there is no feature has been released for that. They just changed the compiler implementation, which means the environment from JavaScript to Go they have changed, and the performance will be like very high. Again, the performance will be based on the code base. And one more thing I want to ensure you all, so we have seen the benchmark of the Microsoft, right? The same we will see in our machine also. Why our performance is not like 10x faster? Because they have their benchmark is based on the machine also. So what machine we have using and CPU score, based on that everything the performance will get increased actually. If you are using low end machine, the performance will be less only, because Go need a parallel worker, right? So that is the reason. And yeah, upgrade with confidence. Please validate also. So before upgrading to 7, ensure all the TS config has been configured properly. And if you want more detail, you can go through the document which is released by Microsoft as well. That is very clear and helpful. With this note, I'm concluding my session. Thank you. And if you want to connect with me here. I'm also upgrading to TypeScript my repo. If any issues, we will connect. If you have any doubt, you can ask.
Doubt session, please. Anyone who has doubt can raise their hands. Hello, guys. Come on.
Okay, all right. Thank you, guys. Oh my God.
Thank you, Roja ma'am, for a wonderful and engaging session. All right, everyone. We are officially earned ourselves a coffee break, and it will be like 15 minutes. Please feel free to grab some refreshment, stretch your legs, or start a conversation with someone who met here. And we will resume shortly, guys. Thank you.
Yes. You guys sure that 15 minutes is enough for your coffee break? You want more or less? More? More or less? More. அப்போ 6 மணிக்கு முடிக்கணும் ஓகேவா ஓகேவா டேய் நீங்களாம் ஓகே சொல்றீங்க நான் ஓகே இல்லை 15 minutes தான் ஸோ the faster you come back we have more time to network and we'll disperse after that, right? So catch you guys in 15. Time right now is, yeah, we'll remind you in 15.
with TypeScript in your day-to-day development, I think it will be very easy for you to answer all of the questions. So the rules are very straightforward. We have 10 questions. All 10 of them are MCQ based questions. So you will be given 20 seconds. And the thing is, you need to answer fast. So how much you are answering fast, you will be getting more points. So it's not only like finding the right answer, also finding them in the very effective speed. Okay. Once we reach the mark 70, we can start. Come on. Also make sure you are giving proper names.
Is anybody having difficulty with the QR code scanning? If so, raise your hands.
You want me to zoom it in?
We'll just zoom into that. Check. Yes, works.
Is everyone joined? Still see 10 people, 12, around 12 missing. Let's give a minute for the other people to join.
55. We start at 60, 60.
Okay. Also, like, the winners will be having exciting gifts, so please play this carefully, because at the end you will be getting gifts.
Audio check. Yes, works. Check. Yes. Okay. So we are at 60. So I think we'll start. Yes. Yanda.
It keeps around like 55, 57.
வேணுக்குனே பண்றாங்களா யாரோ 3 பேர். Right, so we'll start with 60, or since we're also in a tight time boxing situation, we'll have to time box this as well. So shall we go live? Anybody who is still logging in? Even if it's one person, I'll take into account. We'll go slow. Having trouble logging in? Can you use your mobile data? Because the Wi-Fi is maxed out at this moment. Okay. Do you want to team up with somebody? Alright, if you're teaming up, then all cool. Anybody else having difficulty logging in? We'll wait for most of you guys. Anybody else? No, yes. Shall we start?
Shall we start? Are you guys ready?
ஒரு நோ வந்தாலும் நிறுத்திடுவேன். Anybody? Can we start? Yes, no. கேட்ட வரைக்கும் நோ கேட்கல, but let's see.
Okay, let's start the game. I hope the rules are clear. Only 10 questions, 10 MCQ questions. Answer it as fast as possible, okay? Let's start. So the first question is, what does the key of operator do in TypeScript? You have 4 options. Please read all of them and answer the correct one.
யார் லியோ தாசன் யார்?
Times are running out.
லியோ.
Okay, we are done with our first question. Let's move on to our second question. Currently, Hari is leading. Which utility type makes all properties of an interface optional? One is very straightforward. Come on, guys, time is running out. Okay, at the end of second question, still Hari is leading. It's Hari. Okay, the third question is, just feed a block of code. What is the inferred return type of this particular function? Have a look at the code carefully.
ஏய் என்னடா பேர் இதெல்லாம்? மிஸ்ஸஸ் பாய் Pookie. Who the who Pookie? Pookie who? Pookie who? Pookie where? Pookie.
Finally, someone beat Harry.
What? Okay, even Pookie, I'll let it go, dude. Leo Das கூட விட்டுறலாம். மிஸ்ஸஸ் பாய் யாரா யோசிச்சா அதை எனக்கு புரியல. Half of these names are slow student. என்னடா இதெல்லாம்? I mean, anyways, but at least like I think the leaderboard has none of you guys here, so. I think we have a new leader, GK, Syed.
Okay, fifth question was best describes a type code. This is also very straightforward. Okay, still GK is leading. Come on, guys, you just need a small short streak to come to the top. So please be careful and answer. Which of this is not a real built-in TypeScript utility type? Okay, after sixth question, I think it's Syed or Ramita is leading. And the seventh question is again, read the code carefully. What is the precise effect of as const? The thing mentioned in the code. After seventh question, it's Ramita, GK, Samira who are topping the chart. Others, please answer quickly and come to the top. Still Ramita tops. Okay, still Ramita tops. Syed, Sanchita. This is the final question and this has double points. So I believe the questions are very easy. Most of the people are answering instantly. Okay, we are done with the quiz. Let's see the first top 3 places. As I told before, the top 3 will be getting the
Sure.
gifts. Let's see who is third. Sanchita. Can you please come?
என்னடா விசில் அடிக்கிறான் எவனோ ஒருத்தன் டேய்.
Sanchita, like who is Sanchita here?
And if you want to whistle. It's okay, fine only. ஒரு ஆள் மட்டும் பண்ணுங்க போதும். I think Sanjita has fans. Give good round of applause for Sanjita who's joining us on dais. Nice. Third place க்கு whistle வந்துருச்சு. First 2 place க்கு ஏதாவது பண்ணனும் நீங்க தான் முட்டு கொடுக்கணும் உங்க ஃப்ரெண்ட்ஸ்க்கு. யாருன்னு பாப்போம். Next.
Let's move on to the second place.
I'm guessing Leodas. Well, no.
Raz.
எனக்கு தெரிஞ்சு மணி ப்ரோ அந்த இடத்துல ஃபுல்லா ஒரு ஆள் மட்டும் ஏ யூஸ் பண்ணி ஆன்சர் பண்ணிருக்காங்க. மூணாவது வினரும் அதே ஏரியா. நான் கடுமையாக இந்த கேள்வி கேட்பேன். லாஸ்ட் ஃபைனல் பிரைஸ். மணி நீங்க தான் பிரைஸ் கொடுக்கணுமா?
Okay, and the ultimate
லாஸ்ட்
winner
பிரைஸ்
is
அந்த இடத்துல இருந்து மட்டும் வந்துச்சுன்னு வச்சுக்கோங்க. கன்ஃபார்ம் கண்டுபிடிச்சிருந்தா இப்போ
Ramita Chaudhary.
ரமிதா சௌத்ரி. எங்க கன்ஃபார்ம் ப்ரோ அந்த ரோல் ஏதோ பண்ணிருக்காங்க ப்ரோ கன்ஃபார்ம். But yeah, huge round of applause. Nice. So nice, you guys got your goodies. So we do have one more, but again, it purely depends on the time if you're going to be able to do it. We're going to go for the next speaker. Do you guys know who the next speaker is? Our பேர் சொல்லனா வர மாட்டேன்றாரு அவரு. You had to like give him some energy, you had to like hype him up a little bit. Who's the next speaker? Mani, right, so Mani is going to be joining us on stage with his next talk. So we'll start in just a bit. Sri, do you have anything to cover for Mani? I think you can give the introduction for Mani. அவருங்க பாருங்க நீங்க கை தட்டல கிளாப் பண்ணல கூப்பிடலனா வர மாட்டாரு அவர். Mani
hello.
Hello. So now we are moving to our third speaker. We have Manikara Jagannathan, a senior software engineer at Talentship. With over 7 years of experience across Python, TypeScript, and cloud-native systems, today he will be taking us through same editor, smarter agent, what compiler context unlocks. So let's put our hands together for Manikara Jagannathan, sir.
Yeah, thank you for that, everyone. I think we had a wonderful, fun quiz session. So before we proceed, so welcome and thanks for coming on Saturday. So quick show of hands. How many of you have been using coding tools like Cursor, Cloud Code, or Copilot on day-to-day basis, or have experience using them? I can say so many hands raising, almost all of us, right? We have been depending on them to write codes, to debug, to navigate code bases. So yeah, I will tell you a dirty little secret. So behind all the fancy LLM magic, what if I say like it's just doing the basic text search at the binary level? Yeah, because that's what it's doing. It just grips your code base at a faster rate. Yeah. So today I want to talk about why that happens, and more importantly, how can we fix that by providing the same intelligence that's powering your editor right now. So I'm Manikandan, senior software engineer from Talentship. So before we proceed, let's be concrete about the problem. So what your agent need to find something. So what if the agent needs to find something in your code base? What it does, it directly starts gripping. Yeah. So it just do rip grep. Different kind of grips are there. So agent start away triggering the gripping tool. It jumps into search for the start making string matching, and once it finds the appropriate match, it just builds up a context and sends to the LLM, and the LLM decides whether it's the correct code base or not. So that's what it's happening. Meanwhile, the same editor you are using, so you guys can instantly get the intelligence, like if you right click on the function, and you can instantly find where is all the references that particular function is used throughout the code base. So that's no time delay, so it's definitive. So same code base, same CPU, same repo at the same time. The only problem is that the agent is entirely disconnected with the compiler intelligence. So that's our problem here. So because I've actually see it played out. So what happened, like, so I just wanted to rename a particular function. So for the task, so what the agent did, so it went through, it completed the task and took like 5 complete iterations. So it tried to find the reference, and it will inspect, build up the context, make the edit, and then run the test cases to make sure, so is it correctly applied or not. So like that, it went on and on for five different iterations. So meanwhile, if a human is doing that particular operation, same operation I'd say, so it's 0 iterations. Yeah. So what you have to do, you just have to find the particular function is where all the places it's referenced and do the rename. So that's 0 iterations. So that's the problem. So compiler already knows the answer, but still the agent chose to take the longer way. So let's see how we are fixing today. Yeah. So I think, like, from the previous speaker, so she mentioned something about TypeScript language server. So can anyone say, like, what is language server? Anybody? Why is it used? Yes. So it's not only for auto completion, but it's correct. It's the entire intelligence. So whenever user opens a TypeScript based project in an IDE, say VS Code or Cursor, or any IDE for that matter. So what happens, the IDE spins up the language server behind the, under the hood, it spins up the TypeScript server. It compiles the entire code base and builds up the syntax tree. Yeah, so as mentioned before, our previous speaker, it runs the node and it creates the entire context. So that's how when you hit F12 or go to definition or find all references, or if you are typing or creating something and you find the auto correction, right? So the red squiggly lines, all of those because of this TypeScript language server. This is what's powering under the screen. Yeah. So now we know. So this is the intelligence that's making it possible in the editor. So our proposed solution is making the agent make use of this intelligence. So what's stopping us from doing that? We'll see in the next slide. So that's where we have something called LSP. So why the agent cannot directly establish a connection to the language server means, language server communicates in a particular protocol called LSP. Yeah. So language server protocol. So this protocol is specifically built for establishing a connection. So client and server side connection. The client side is usually the editor, and server side is usually the language server. So that's for in this case, the TypeScript, it's a TypeScript language server. So it can be anything. For Python, different one. For Rust, it's a different one. Yeah. So bottom line, so LSP, it may sound fancy, but it's just a protocol. So it's working in, so as I mentioned here, it's working in JSON RPC. Yeah, it's structured in a way. So think of it like as I said, like client is the editor. So if a user in an editor tries to find the definition of a particular function, the client will ask, I want to find the definition of this function. So so the particular message will be framed in a JSON RPC and it will be sent to the server. The format will be in the JSON RPC. And the TypeScript server, what it does, it resolves the exact function definition with the file name, with the row, with the column and everything, because it already has, it already mapped out the entire code base, top to end. So we know, so the problem right now, what we have to make the agent make use of TypeScript language server, because TypeScript language server only understands LSP. It doesn't speak to agent. Yeah. So also while we talk about LSP, it's also better to look back how history about LSP itself. It's worth mentioning like 30 seconds about it. So what happens like LSP is something like it's created at 2016, like 10 years back from now. So before that, so before LSP, so there also we had editors, we have developers created codes, we have TypeScript, everything is there. So how did the intelligence happen? So that's when like, so for creating, if I have an editor and I want to support TypeScript, what I have to do? I have to create my own communication layer for TypeScript server at the editor. So at the client side, I have to do my own integration. At the server side, I have to do my integration. Similarly, for the different editor, for the different language, I have to do the same thing again. So for, let's say for 5 browser and for 5 different languages, so that's 5 into 5, 25 repeated operation. So what happens? So a group of team, a group of developers decided let's not do that. So they came up with a common protocol called LSP. So with this, so for TypeScript, so they have defined a server side, and also for the same TypeScript server, they were created a server side integration. So suddenly M cross M issue became M plus N. So instead of doing 25 implementation, so they ended up doing only 10 integration. So 5 plus 5 it's 10. So why I'm telling you this? So the thing to take away is that nowhere it is mentioned that client side had to be editor. So if anything, so even if you are creating your own implementation, client side implementation, as long as it talks JSON RPC, language server will resolve. So will give the answer. So that's what our solution. So the solution is to have, so what happens like on one hand we have the TypeScript server that only talks JSON RPC. On another hand we have the agent that can make use of MCP. So show of hands, can anybody explain what's MCP? MCP. Yes. Model Context Protocol. Yes. So true. So can anybody explain what is MCP?
It's basically used to call external tools. A protocol for AI agents, external tools like or anything.
True. So basically, to sum it up, so it is a strand that Anthropic came up to establish or to equip an agent to give additional capabilities. Yeah. So agent can interact with LLM. So on top of that, if you give additional MCPs, that means you are equipping your agent to do more. So it's the bottom line, we need an MCP for agent. So we have an MCP that's called agent LSP. So what it does, it particularly solves our use case. So our problem is that TS server cannot talk apart from JSON RPC, and agent can only talk with MCP. So the communication layer we can establish using agent LSP. It will act as a transfer. So agent LSP translates the agent query into a TS server understanding format, JSON RPC. So as you can see in this representation, so if a user want to find a symbol, the agent will trigger a query to the agent LSP. The agent LSP will simply frame the JSON RPC and TS server will resolve with the answer. So because TypeScript server, it already has the entire code base compiled and readily available. So that's the context graph. So that's of the flow. Now we have the connections established. So it has formed the complete circle. So yeah, okay. So I said like we have fixed the problem. Now the agent can start using the compiler intelligence. So few may ask, so why we do that? I already have the working solution in hand. So and it works. Even today, developers are start using the agents for developing coding. Yeah. So let's see. So the difference is in philosophy itself. Like if the agent is doing a grep, let's just say if it wants to find a function called get user, the LLM will try to find the get user, but what the grep gives, not only the particular grep user, it will fetch all the reference of it, even other private functions or the same particular declaration in a comment section or in a dead code, or in instead of like get user, it will try to get user by ID because it sounds similar. So what happens? So that's one iteration. After that, it will send the entire context. So whatever it had fetched first, it will send to the LLM. So that's the context window that's keep on growing as your code base increases. Yeah. So LLM will decide. It will try to compile and connect dots which you already have in the LSP. TypeScript server already has the compiled and everything is available as a node. So meanwhile in LSP, everything is symbols. So in case of grep, everything is text. In case of LSP, everything is symbol. If you want to find a function, that's finding a symbol. So our agent LSP MCP is also equipped with like 60 plus tools for performing various operations. Like we can rename stuffs, we can find stuffs, we can go to definition. So all those stuffs I can show you later. Yeah. Okay. So apart from that, so in cost point of view, so whenever like in a normal grep way, so whenever agent tries to find something, it opens a file and look for something. Let's just say the same example we used before, like get user. So it tries to open a file, or even at the directory level, it will run a grep, and to make sure it will read again all those files, build a context, and run the iteration. So inspect and do the cycle. So that's directly reflects to more files open, and it will increase the token size, and also like iterations we have talked before, like it will infer, it will inspect, it will again do the same thing again and again until it finds the until it resolves the task. And also like by using LSP, we can also reduce token because the context size itself is reduced. Why? Because like the iterations can be eliminated and fewer files are open. So all in all, it sums up to token, because what matters is like as long as like we are doing coding using agent, it's at the end of the day, it's token burning, right? So whatever we are building or whatever we are trying to do, maybe we are just trying to fix a bug. So what happens, like how soon it can do? So it can take happen in a minute, or it can take an entire day. So at the end of the day, how it's going to translate? It's going to burn up token. So that's the advantage. We can minimize that by using LSP. So what happens, like how is it possible? So every grep, so that is like it's not definitive. So but every LSP resolution is a definitive answer. So that's why it can reduce the iterations. Okay, so I have a demo plan for showcasing this. So this is the plan. So I've created a TypeScript code base, and I have a clone of that. So I basically have a 2 workspace. So what we are going to do? So we are going to search a function called like calculate total, and I want to rename that particular function. So that's the calculate total to calculate order total. So let me show this. Yeah. So it's just a cursor window. Let me increase the font size. So this is the TypeScript project that I created for specifically for this demo purpose. It has like 140 plus TypeScript files. So and also I have I have enabled the MCP, so agent LSP. So the LSP tool that we talked before. So this has like 62 tools built into it. So once we wire this, the cursor agent can start using this LSP. The integration is like this: cursor, MCP JSON. So I'm sure like you guys know how to wire the MCP to the AI agent using an MCP. That's a .json. I can show you that also. Yeah. So this is just showing the path in my Mac, so where the TypeScript language server is referenced, and also like agent LSP. So I have installed in this particular path. So why? Because I want to show like both agent LSP and TypeScript language server are running in my Mac. Yeah. So we can also check whether it's working or not. So just to show you proof. Yeah. So the TypeScript language server is 5.3.0 and agent LSP is up and alive. Back to the cursor. So basically I want to do rename for this particular calculate total in this pricing. Yeah. So for that I created a simple prompt. So rename the function calculate total. So I have to provide a file name also. So that's why usually the agents will start framing the request to the MCP. So because it's a required parameter for the MCP. So can anyone explain like how the agent triggers an MCP, the flow? True. So, but what happens after that? So as long as the agent decides it needs an MCP, so it goes and see that MCP is available or not, and it decides the particular tool it can use for that. So for each tool, the MCP server will provide a JSON. So the like parameter JSON, schema JSON. So based on that, to trigger a particular tool, it will create parameters. So in that case, to rename the symbol, it needs a file name as a parameter. Yeah. So we'll see it live here. So as I told before, like these are all the JSON files. So for MCP that's already providing. So based on this JSON, it will create the MCP call. Yeah, back right. So based on this, it will create these parameters for MCP calls. So it's already done actually. So it has renamed all the files, 107 references actually I've counted. Please believe me on this. Yeah. So what we can do, we'll use the same instruction and do this in a normal, normal way. So this cursor window does not have, does not have the MCP integration or anything. I'll show you. So this does not have the LSP MCP enabled. So by default, this cursor can only use grep. So I'll give the same instruction. The instruction is to rename the function calculate total to compute order total. So let's see what it does. So it understands the instruction and it started grepping for the calculate total. And again, it's trying to understand. So So again, it again established a second grep, and it's trying to find out like what are all the real call sites and what are all the, like as I mentioned before, comments can be there, dead codes can be there, the same function in the same name in a different module will be there. So it tries to do that. So everywhere, every time it's trying to do that, it's the call to the LLM so that it's directly resonates to token. Yeah. At the end, we got the output. We have the output. I'm not saying it won't do that, but what happens, the number of iteration it took. So that's what I'm trying to prove here. So again, we got back 107 instances. As you can see, so for the same instruction, a grep here, again 2 greps here, again grep here. So in some cases, what it does, it after applying the changes, sometimes it if the unit cases are available, it tries to run the unit cases and everything. So that's what I'm trying to say. So in a rapid development environment, these stuffs matters. So because what happens, like at the end of the day, maybe like how many I don't know how many of you guys are using your own account, or how many of you are using your company's account. It's going to burn up the capex, right? Let me get back to the presentation. One second. Okay. So this is the numbers time. So for the operations that we did, I could able to capture the number of tokens it took for a single session. So the cursor provides that in the under the usage section. So what happens, like by using a normal grep operation, it took like 295k token, and in the MCP way it took like 175k token. I'm not saying like it always, if you go to, instead of like a normal grep operation, if you go to LSP, I'm not saying like you would always get 40% improvement. So the numbers are subjective. It mainly depends upon the size of the code base and how complex is your code. If you use like more number of abstraction layers and production grade application, obviously it's going to the numbers are going to vary. But what I would say, in all the blog posts or community benchmarks I've seen, the numbers are in the current direction only. So LSP is always better than normal grep. So I would like to point out, like I've used the rename thing because it's the easiest thing to demonstrate, but the actual use case is beyond simple rename. So using LSP, or by enabling LSP to the coding agent, so mainly like it will give the potential to the agent to navigate your code base more effectively, and it helps to understand the code base also, because all the symbols are already compiled and readily available for the agents, and also like at the time of planning also. So what happens now, if you want or ask the agent to do something, the agent, what it does, it makes the edit and then runs the test, and it try to fix. Yeah, unless you want enable the planning mode and try to sketch it out yourself. So what happens, that's what is happening right now. But by using LSP, it will run the blast radius and everything. Even before making or touching a particular function, LSP will run a blast radius, and it will come up with area that would get affected. So that's a special tool for planning itself. So finally, like I would like to sum up. So by enabling your agent with LSP, so we get back like these 4 capabilities. So faster operation, lower token cost, deeper understanding, and enhanced accuracy. So why the faster operation? Because what we are trying to challenge or replace, I would say, is the semantic queries against a normal grep operation. So that's where it takes a lead. And lower token cost, as we mentioned before, lesser iteration, lesser files opened, and it directly leads to lower token cost. Deeper understanding, as I mentioned before, agent have direct access to your entire code base, not just the text of the code base, because for LLM, everything is just a token. But using LSP, it gets access to the entire semantic tree. And also like enhanced accuracy. So why? Because if you want to find something, compiler already knows that. Now the agent also knows that. So the same editor, smarter agent. How it is possible? Because of agent LSP. So finally, so as I mentioned before, the LSP and it's not only, I'm not saying like it's only working for TypeScript. Since it's a typed code event, I picked a TypeScript server and a TypeScript project for the demo. The implementation is more. So we don't have to, so the bottom line is like we don't have to invent anything. We don't have to design a system to do that. We already have the MCP, we already have the intelligence, the editor intelligence, that's the TypeScript server. The solution is to, we just have to establish a connection and start using it. And only by start using it, we can know whether it will work out or not. Because in my case, it is working out. So it depends on the code base, size of the code and the complexity and everything. So what I would ask you guys to do before opening up for question, so I would like to go and try doing this. So I'll provide a link for the GitHub repository and how I did that. The agent LSP is a Go based package that can be installed using a brew or in a CLI itself. And also like TypeScript server is also a open source node package. Anybody can install it. So please go ahead and give it a try. And I'm opening up for questions. Any questions? Right.
Guys, do you have any other questions to ask them? Please use this opportunity, man.
So this is my GitHub link and LinkedIn profile. So please connect. I'll be available outside. If you have any doubt or want to dig deep into it, you can reach me. Later today, the best way to reach me is by LinkedIn. Thank you for your time. Thank you for your patience. I know it's Saturday evening. Back to you.
you guys sure? Do we really have a fourth talk? No one was objecting. Any guesses what is going to happen next? Okay, then let's go with the fourth talk. Okay, right? Yes. Great audience.
Hello, good evening, guys. Here. Hello. Hi. So, who is following TypedCoders pages and all in LinkedIn? Everybody would have been followed, so that's why you're here. But you might wonder, like, there is nobody. I mean, you may not see me in any of the posters. Did you see me in any of the posters? No, because this is a surprise tech. And are you interested in taking this? I could hear only the yes from this row. Are you interested for the next talk? Once again. Cool. But don't worry, I'm not going to take this as a talk, okay? We'll have a fun game. So it's just, you're going to raise hands and you have to answer. If anybody answers, apart from the person who raised hands or stood up, they may not, like, that answer will not be considered, okay? And moreover, like, who doesn't know English? I mean, who's not well versed with Tamil, sorry. Any non-Tamil speakers? One. Okay. I think some questions may not relate to you, but there are some questions that relates definitely to you. Okay, let's start. Yes, yes. So, guys, you're going to guess the word, okay? Who ever know about the game called Connections, where we have multiple pictures and you have to guess the word, right? Are you excited? Okay. So I thought like people were not excited about the tech sections, but I see all your faces are blooming up. Okay, we'll go with the first word. Are you ready? But sorry, we are not going to give any gifts for this. It's just for your brainstorming sections, okay? Raise hands. Yeah, the black sheet. Cool. Yeah, so maybe like we'll go one from this side and one from this side. So what's your name? Govin. So he has said the correct answer. Can you just shout out one more?
Kubernetes.
Okay, cool. We'll go with the next word. And I need it from this side, okay? Raise hands. Do not shout the answer loudly. If you know the answers, yeah, you?
Security.
Cool, super. Okay. So have you wondered how this word came? Now you're able to follow it, right? It's seeing. Okay, the next is from this side. People who raise first. People who raise hands first. Yeah, you. Obviously. Because that's why the reason I said you, some questions may not relate to you, okay? People who don't know Tamil. Who's the second person? So if you know his name, then this answer is pretty easy. Go with the next one. And I want answers from this side. And I get only answers from the first two side, and I couldn't see anything from the back ends. Okay, I think this is a pretty difficult one. Okay, whoever answers this, there is a prize for them. Close. So what's this? What's this basically? The center one. Yeah, you?
Runtime validation.
Correct. Yes, answered. Good. How did you find it?
Other hint. Days, sun.
Cool. Can you just give him a round of applause? This is very easy, and I said the answer. I'm sorry. I'm sorry. I'm sorry. I'm sorry. Okay, we'll move on to the next one. Okay. Someone from this side, and I'm going to give the gift for this side. One gift for this side, for this answer. What they are doing? I'll give you a hint. What they are doing?
Test coverage.
Correct. And can you just explain me, because other persons also want to know what is it?
I mean, he's writing a test that's a cover and it's old.
Okay. Can you give him a round of applause? The next one. This is, I think it is easy one. And the answers from this side. What's the place called? The first, what is the place called? Then you would have that. This side.
Docker compose.
Exactly. That's the right answer. Good one. Can you explain me, because like other? Okay.
That's a dock, a car.
Can you keep the mic closer? Yeah.
Is it audible? Yeah. Dock. That's like the sea dock. That's a car that's come and he's posing for a photo.
So it's basically like the ships where it stays, it's called as a dock and car, and he's still in come, and that is a pose. The person who answers this will not get any because I know everyone will answer this. Yeah. Okay. Because from this, everything seems to be pretty easy. Yeah, you?
Wireless connection.
Great. So if you would have followed politics, definitely you would have known this. But it's technical.
Incognito.
I'm going to give a gift for this.
Incognito mode.
No. Anything from this side?
Internet protocol.
Exactly.
So that is LinkedIn, that is Star and Net, Parota and Protocol. Calling.
Great. So this is very easy and everybody knows. No gifts for that. No, it's technical. I'm not into science. It's technical. Exactly. Anthropic? Hmm. Yes. You know the answers?
Read only
Read only
memory.
memory. So, yeah, I think I'm done with it. Did everybody enjoy this? And can everyone give a round of applause for who answered? Thank you, thank you. You're so much awesome, guys. Thank you.
And now we move on to a very special part of today's event, the felicitation of our speakers. A great event is possible by great conversations, and we are truly grateful to our speakers for taking the time to be here and share the expertise and makes today's session meaningful for all of us. I would like to invite Ms. Shanti to felicitate our Danny Akash sir. Let us give a round of applause for Danny sir. I would like to invite Jaysilan sir to felicitate Roja ma'am. And I like to invite Haripriya ma'am to felicitate Manikandan sir. Haripriya ma'am, can you stay back to give gifts for volunteers? So can I call about volunteers, please? The Pavan sir, Tamil sir, Vinod sir, Partha Sarthi sir, Mani Raman, Nitin Kamalesh, Satish, John Lee, and Jaysilan sir.
We are not that old, okay? So offensive. We are not that old.
I really appreciate all the volunteers who were involved in this event. Let's take a moment to appreciate them as well. Without them, this event is not at all possible. Yes, Vinod. Tamil? You got it? Pavan? Manigandan Raman? Satish Durai? Sarathi? Nitin Kamalesh? Alais Rambo? And Jay Silan. I also would like to take a moment to thank our MC. You can go and collect your gifts. On behalf of interns, I would like to call Hari to come and collectively get a gift. Now I'll hand over the mic to our MC back. Thank you.
I So I would like to welcome Hari Priya to facilitate Shati Pam, who is an event organizer. So I would like to invite Jay Seelan to give a thank note of our event.
Good evening, everyone. I hope you will be happy for this today wonderful session. I believe you all learned something meaningful and new today from your today's session. Yes or no? Yes. Okay. Thank you. First of all, it's Saturday actually, so you spend more time and you're willing to learn and you improve your career by learning new concepts. Thank you for your time, first of all. And I would like to take this wonderful opportunity to thank you for our speakers. The way you explained the concepts very meaningful and simple and practical way, right? So thank you all our speakers. And I would like to take this opportunity to thank you our management for providing such opportunity to conduct this kind of sessions. They are supporting us every year to conduct this kind of session, say TypeScript or JavaScript. Thank you, Hari. Yeah, and our special thanks to our organizing team members. Thank you, everyone. So the way you run the session last 2 weeks was wonderful, and the coordination, everything is coordinated very well. And last, first not least, thank you for all your active engagement today. For your time and your learning. Keep learning. Let's not just stop here. Just to try to apply the learning you learned today with your real world active development work as well. Thank you everyone.
Let me add one more thing also. So without facility team and the building team, it's very hard to do an event in a venue. So let's all give applause to the building team. They are hearing us, but எல்லாம் இந்த செஷனை முடிச்சு போனதுக்கு அப்புறம் just appreciate them by saying thank you. Thank you சொல்றதுனால யாரும் எந்த இதுவும் விட்டு போகல. சரிங்களா? So have a great evening. Cheers. I'll just pass to MC back.
Now let us move on to our feedback session. Please scan the QR code displayed on the screen and submit your feedback. So please take a few minutes to complete the feedback form. Your feedback really matters to us. So can we wrap up?
Your feedback really matters a lot to improve. So do send us feedbacks. Also, a quick shout out to our community partners, Chennai React JS, She Builds Chennai community, and D3 community. Anyone from this community? Yeah, good to see. And we do have a feature where you can generate your certificate stating you have attended this event, which is available in our TypedCoders website. You have to enter your registered email ID and generate certificate. It will be coming to your email ID. If you face any issue, you can send us email to events@talentship.io, which will be also available in the website itself. The instructions are available in the website, and this is the QR for the website. Okay, how many of you got your goodies tokens? Does anyone doesn't got? Like who didn't get? Okay, you guys can come and collect. We have few more goodies token available. Okay. Yeah. Can you guys come and collect the tokens first? It is again 18 only. Again, first come, first serve. But don't, like, repeated people don't come, please. Thank you. You can. If not, you can send if not, you can send email to this mail ID, which is anybody else? Already got it. The next step will be how to collect your goodies and assemble for a group photo in the lobby, and there itself you can collect the goodies as well. And thank you so much for staying patiently with us. Thank you so much.
Thank you guys for being a part of TypeCoders. So a huge thank you to Talentship for bringing everyone together and making this event possible. A massive thank you to our speakers for sharing your time and experience and knowledge with us. So thank you all for the organizers, volunteers, and everyone working behind the scenes. And most importantly, thank you for making a Saturday spending with us. We make sure that it's worth it. It's up to you. So keep learning, keep building, and keep asking questions and keep connecting. And most importantly, keep typing. Thank you everyone for being a part of TypeCoders. Have a fantastic day ahead, and we will see you at the next one. Until then, happy coding. Thank you.
First, let's assemble for a group photo followed by goodies collection. Hello.